kids, it's Miss Witt. I'm talking about your homework tonight, which is we're wrapping up lesson 3 of topic 2. Yesterday or last night we did the skill worksheet, which was division of fractions with a whole number and a fraction, and we were using the number line to help us do the division. But mostly it was also so that we can recognize when we see a model, which division problem it goes with. So tonight you have the assignment. You were told in class that you only needed to do the practice, which I wanted you to do all of it. So I'll do one problem, and then I might make up a couple to talk about. On the lesson 3, they actually gave you all the different activities have strategies. Like, one strategy was that you can do the inverse, change it to multiplication. And then another one is you can do the number line, or also you could do the keep, change, flip, or we talked about today the keep, change, reciprocal. And that's where you do flip the fraction. So anyway, you can do whichever strategy you prefer. I might do one with the picture and as a model, and one with the keep, change, flip, or keep, change, reciprocal. So I'm going to do number 1. So the first thing is we have 2/5, and we're dividing it by 1/3. So I'm going to keep the first fraction. I'm going to change my operation to multiplication, and then I'm going to do the reciprocal or the flip of the second fraction. So it will not be 1/3, it'll be 3/1. At this point, I'll look at my numerators with a denominator and see, can I simplify ahead of time? It makes my life a lot easier. So I say, can I do 2 and 5? Is there a number that goes into both of them to make it so that I can divide into both of them? That would be the common same number that would, simplify or make this fraction smaller. I don't have one that comes to mind. What about 3 and 5? Do they share a common factor to divide with? No. What about 1 and 3? No. What about 1 and 2? No. Remember, if you do this, it has to be a numerator with a denominator. So there's no way I can simplify, so I'm just going to multiply across. So 2 times 3 is 6, and 5 times 1 is 5. I did not specify tonight that you to simplify, so I'm going to have to accept 6/5, but this would definitely be an answer if you had to do graded response. But if you simplify, I might give extra credit. So probably only those people that watch this video is who I'm going to give the extra credit to. So if you're one of those people and you watch the video and you simplify, I want you to come up and tell me when I'm calling out grades tomorrow. You'll just come over to me and you'll say, I watched the video, so I'm going to get extra credit, okay? So this is going to be our little secret. Don't tell anybody else, okay? So 5 can go into 6 one time, one whole, and you'd have 1 left over out of 5. So this would be the simplified answer. I'm going to go down to number 8 actually, because I probably need to do one like this as well, because now I see some mixed numbers. So I see 7 and 1/3 divided by 1 and 2/3. I cannot divide or even multiply if I have mixed numbers. You have to change it to a mixed number or to an improper fraction. You can do that by doing the check mark like I talk about in class, or you could do the little roundabout thing, whatever's easiest. So 7 times 3 is 21, plus 1, I have 22/3, divided by 1 times 3 is 3, 3 plus 2 is 5/3. I think that bottom number was 3. Yeah, good, I was just double checking. Okay, so I have 22/3 and 5/3. So now I have to keep, now I have my division problem the way it should be. Now I gotta rewrite it as a keep, change, flip. So I'm going to keep my 22/3, change it to multiplication, and do the reciprocal and flip the second fraction. Is there anything I can simplify at this point? Can I do any denominators and numerators together? Well, I can't do 22 and 3. There's no number that goes into both of them. That's the same. I can't do 3 and 5. There is a number that goes into both of them, a common factor that is the same. I can't do
Javante and Jemiah Blake to the front office for checkout.
I can't do 22 and 5. There's no number that goes into both of those. That's the same. But I can do 3 and 3. Actually, both of these numbers are divisible by 3. They have a common factor of 3. So 3 divided by 3 is 1. Cross that out. And 3 divided by 3 over here is 1. Cross it out. You may even want to rewrite your whole entire problem again if you like. You can rewrite it as 22 over 1 times 1 over 5 and work that out. Now I have 22 fifths. This would be okay to leave it as improper if I was gridding. But if you simplify and you say that you watched this video and you get extra credit, I'll take extra credit. 5 goes into 22 4 whole times with 2 remaining out of 5. This would be the correct answer if you simplified all the way. So I did 2 problems from your practice. There we go. And you didn't have to do the stretch. And so let's go to the back side, the review. On the back side, I said you need to do number 2. It's a word problem. So you got to pay attention. It says Ling is a camp counselor at a local summer camp. She's in charge of the weekly craft for 40 campers. I usually like to box any number I see because this is a math problem. So numbers are probably important. It says she plans to make fabric-covered frames that each require 1/6 yard of fabric. The camp director gave her 6 2/3 yards of fabric remnants for this project. Does Ling have enough fabric for her craft activity? So we will work out our problem. To me, this looks like it's a division problem. So we would do 6 2/3 divided by 1/6. Now, can I divide it the way it is? Nope. You have to do the check mark. Now, if you look at number 3, we have the prime factorization for each number. We have to determine the greatest common factor doing this. So this means you're going to be doing your tree. So you're going to do the 28 and 32, and you're doing the tree and breaking it down to its prime numbers. So what can 28 be broken down to? It can be broken down to 4 and 7. 7 is a prime number. The only thing that equals it is 1 in itself. Again, this is back from topic 1. 2 can be broken down to 2 and 2. They are prime numbers. So if they wanted you to write the multiplication products of the prime numbers, you would write 2 times 2 times 7. You also might see it as 2 to the second power times 7. Okay, your next one is 32. So you can do 4 times 8. 4 can be broken down to 2 and 2. 8 can be broken down to 2 and 4. 4 can be broken down to 2 and 2. So if I was writing the product of my prime numbers for this one, I'd write it as 2. Whoops, let me see if I can move it up. I'd write it as, oh, there we go. 2 times 2 times 2 times 2 times 2. And what does that equal? If I wrote it with exponents, it would be 2 to the 5th power. But now I just did the prime factorization for those two numbers. But they say you can use the prime factorization numbers to come up with the greatest common factor. So this is where, when I taught this, we would cross off our matches. So you could easily do it like this. You could say, well, I have a 2 here, and I have a 2 here. So I'd say 2. I have a 2 here, and a 2 here. I can add another 2. Now I have a 7 up here, but I do not have a 7. I have a 7 here, but I do not have a 7 down below. And I have 3 2's here, but no more 2's here. So I am actually done. And I can do 2 times 2, which is 4, and that would be my greatest common factor. Now, a lot of you are probably saying, why did you do all that work, Miss Witt? I could have just told you. I can look at the numbers and tell. Yes, but you also need to know how to do the prime factorization to get the product of the primes, and you also, sometimes we don't always get what we think is the greatest common factor. So anyway, have a good night. I'll see you tomorrow, and do not forget, my students, to remind me about the extra credit. Have a good night. Bye-bye.